everybody. Today we're going to be working with experiment 18, also known as acid-base titration curves. The purpose of today's experiment is to understand the titration curves of 4 different scenarios. We will be working with a strong acid, a weak acid, a strong acidic commercial cleaner, and a strong basic commercial cleaner. And we will titrate them against a strong acid or a strong base. From there, we will simply plot pH versus the volume of their respective titrants. To start off, we need to make sure that we're being safe. So first off, we're going to go ahead and switch off, take off our glasses, and put on our safety goggles, as well as have a lab coat on that's fully buttoned up, and our gloves to protect us from the chemicals. The other thing that we need to make sure of is if we have long hair, to make sure it's fully tied back, and as well as make sure our lab coats are fully buttoned up and we are with our proper PPE for the experiment. For the materials that we're going to need today, we're going to need a microlab instrument along with its pH probe that's connected. We're going to need a burette with a ring stand as well as a burette clamp, some Erlenmeyer flasks to hold our titration solutions, as well as differing titration solutions that we mentioned before, phenolphthalein indicator to give us an idea of when we're reaching equilibrium of our titration, as well as some different graduated cylinders to measure out the solutions that we need for our titrations. In the first part of our experiment, we need to make the titrant for our different titrations that we're going to run. First, we're going to go ahead and make our base titrant. The way we do this is we take a 500 ml beaker and we're going to take 15 to 18 mL of 2.5 molar sodium hydroxide and mix it with 400 mL of deionized water. Now that we have our burette cleaned, we can go ahead and fill our burette to the top 0 mark by closing our burette and simply placing the required amount of sodium hydroxide titrant. So once we have our burette filled to the appropriate volume that we need, we're going to go ahead and take our waste beaker off, making sure to label it so that we know it's waste and we don't get it confused with our other beakers that have our reagents. You can set that aside for now. And we're going to go ahead and measure out 25 mL of our 0.1 molar hydrochloric acid. This is going to be what we're going to be using for our titration solution today. So we can go ahead and grab an empty beaker, take that 25 mL, add it to that beaker, and then we're going to go ahead, we're going to add 2 to 3 drops of our phenolphthalein indicator. This is going to help us to identify when we're reaching the equivalence point of our titration. From there, we go ahead and take our beaker, place it under our burette, and take our pH probe from our microlab station, and we're going to go ahead and remove the top cap. Once we have our probe in our acid solution, we need to also dilute it by adding 100 mL of water. We can do this by simply using the same graduated cylinder that we used for the acid solution, as any acid left over will not affect the reaction. Go ahead and take the 100 mL of water and add it to our 25 mL solution to make our acid solution for the titration. Then we go ahead and stir it with our pH probe and allow our probe to sit there and read the pH of our solution. From there, we can go ahead and take it, our beaker setup with our probe, and place it under the burette so that we can titrate our solution. To do this, we're going to go ahead and simply put the 0 volume for our microlab program to allow it to read the initial value without any titrant added to the solution. Okay. From there, we can go ahead and add a known amount of mLs, whether that be 1 or half or what you decide to do. We just reached 28 mL in our titration. At this point, the color is going away a lot slower than before. And so now we know, and this is an indicator to us, that we should start slowing down our titration to drop-wise. Again, if you're adding a drop, it's usually about 1/20th of an ml. So as you're adding drops, how many you're adding, calculate how much that is in mLs and add it onto your XY graph in your microlab program so you can track how much volume you're adding per addition. So we're going to go ahead and take one extra drop, and you'll see that the solution turns white, pink, without changing much to solution color back. But if you keep stirring this for a while, your solution will go back sometimes until you've reached the full equilibrium point. Once you've gotten past this equilibrium point and the solution is no longer changing back to clear, you can go ahead and start adding more drops to get to the end of your titration. You should be ending your titration around pH 12. Okay. Now that we've completed our titration and we've reached around pH 12, I wanted to stress an important part of this experiment. It's very important that you actually see what kind of titration curve you got. Now, as you can see here on the screen, we got a pretty steady increase of our pH based off the amount of volume of titrant that we were adding. But as we got closer to the equilibrium point, as we got closer to the point where the solution was no longer going back to clear, we severely dropped or decreased the amount of titrant that we were adding so that we can make sure that the volume of addition between the equilibrium point is as small as possible. This is going to allow us to have a titration curve that is as straight of a jump up as possible, and this is going to allow us to determine our equilibrium point or its pH accurately. If you do not do this and you simply rush through your titration, instead of seeing this nice, neat jump up, you'll see more of a slanted slope. And this will cause errors in your calculation of your titration's equilibrium point. Now we can begin with our next titration. We're going to go ahead and titrate the acetic acid, weak acid solution that was prepared to us for this experiment. We're going to take a new beaker and we're going to make our solution. Again, we're going to take 25 ml of the 0.1 molar acetic acid. So now that we have our 25 ml of our 0.1 acetic acid, we're going to go ahead and place it into our beaker that we're going to run our next titration in. Using the same graduated cylinder, we're going to add 100 ml again of deionized water into our graduated cylinder. This is going to kind of clear any previous liquid that we have in there of the acid, as well as provide the water that we need to dilute our solution appropriately. Take that 100 ml and add it to our solution. And again, we're going to go ahead and add 2 to 3 drops of our phenolphthalein indicator. The indicator should not change color at this point as we have an acidic solution. Okay. And last but not least, we're going to take the previous sodium hydroxide solution that we made from the first titration, and we're going to go ahead and fill our titration burette to the top. We're going to go ahead and stir our solution, take our probe out of our storage container. We can go ahead and rinse our probe off into our waste container real quickly before adding it to the acidic solution. We can go ahead and take our beaker, place it under our burette, input our 0 volume into our experiment to get an initial pH reading, and then we can go ahead and continue with the same procedure that we did for the first titration. For the third titration, we're going to go ahead and use a commercial acidic cleaner. For this experiment, you should be provided with the Lysol toilet bowl cleaner bottle, which will act as your commercial acidic cleaner that you will use for this titration. So to start making this acidic solution for this part of the titration experiment, we're going to go ahead and take our beaker, we're going to place it onto our balance and zero it out. Once we have it zeroed out, you're going to go ahead and take your Lysol toilet bowl acidic commercial cleaner, and you're going to weigh out about 5 grams, or sorry, 0.5 grams. Once you have the 0.5 grams, We'll go back over to our workstation where we'll dilute it and add our phenolphthalein indicator to continue the titration. Now that we've acquired our 0.5 grams of our acidic commercial cleaner, we go ahead and dilute it by adding 60 mLs of deionized water to a graduated cylinder and adding it to our solution. Remember that we need still our phenolphthalein so that we can indicate our titration's equilibric point. 2 to 3 drops of our indicator should suffice. We'll give that a stir, making sure our burette is filled to the 0 mark, and we can go ahead and begin the third titration of this experiment. For the final titration of our experiment today, we're going to go ahead and make the basic commercial cleaner solution by taking our beaker again, placing it on the balance, zeroing it out. Now we're going to go ahead and take liquid plumber gel, that's drain cleaner, basic solution. Be careful with this as it is caustic. And we're going to measure out 2 grams into our beaker. From there, once we have our 2 grams, we'll take our beaker over to our workstation to dilute it, add our phenolphthalein indicator, and continue the titration to finish this experiment. With the burette's titrant changed from a base to an acid, and our basic commercial cleaner solution made with the phenolphthalein indicator included, as well as the probe for our microlab program, we're ready to begin our final titration for this experiment. Go ahead and take a 0 volume initial reading and input it into the microlab program, and then you can go ahead and begin adding known amounts of your volume of titrant and input that into the computer to complete the titration. Again, remember, this titration is opposite of the previous ones that we ran. So instead of seeing a low pH to a high pH change, we're going to be seeing a high pH because this is the basic solution that we're starting with, and we're going to be moving to more of an acidic pH as we add more of the acidic titrant in the solution. So for the final titration, the indicator might not be as clear of an indication of whether or not you've reached your equilibric point. This is the reason because of the fact that the liquid plumber basic commercial cleaner has 2 different bases in it. It has a strong base of sodium hydroxide and a weak base of sodium hypochlorite, or also known as bleach. There might be some fumes that come off of the titration that are basically the bleach smell that you're going to be smelling. So if you do feel faint or if you do feel a little bit unwell, step outside and get some fresh air or alert your TA for further instructions. Once completed, you'll go ahead and you'll identify the different equilibric points from your graphs and calculate the information that the report sheet has asked. If you have any further questions, speak to your TA. They're more than willing to assist you and show you the ropes on how to get through this titration experiment with ease.